Okay, 3.3, quadratic functions, and guess what? Applications start today, day 4. Okay, so think about what we've done to this point. We have remembered characteristics. We graphed it the old alg 2 way. We have graphed them the new alg 3 way by changing them into vertex form. We have then written equations in vertex form, and now it's time to take a look at some applications. Good news. Some of you are going to be very, very good at this. It's just the graphing calculator stuff all over again. Bad news, some of you aren't going to be good at this because you haven't been practicing with your graphing calculator. So, hopefully the video today, you watching this, you'll be able to pick up what I'm about to put down for you. Alright, so take a look. Letter G. Quickly read that to yourselves. The advice that I would give you when we do these word problems. Read everything. Start to finish. Underline, highlight, bold, whatever you feel is important, and we'll kind of go from there. All right, so first thing that I noticed, obviously the most important thing is that the football models that function right there. So I know there is the football. I know, that kind of looks like projectile motion that we've done in the past. So hopefully you got that down. H equals negative 16 t squared plus vt plus k. Hopefully you remember that from here. So it says the height, where h of t represents the height. Obviously it's in feet, and t is in seconds. So if you need to underline, height is in feet, time is in seconds. It's going to be important when we kind of go from here. All right, so what does the y, letter A, what does the y-intercept of this function represent? So think about that. Here is my function. Voila, there is my y-intercept. I know my y-intercept is positive 1. Well, if you remember from projectile motion, what does that positive 1 represent? You should be saying it's the starting height of the football. So that means that the football started 1 foot off of the ground. So hopefully, so far so good. Height of the football, 1 foot off of the ground, and got it. Letter B. After how many seconds did the football reach its maximum height? Well, now it's time. I know what we need to do is we need to graph this. I want to see this football in action. I want to see the shape of that parabola. What goes up must come down. So what we're going to do is we're going to go to our graphing calculator and let's graph this function. So let's head to our graphing calculator. Here it is. Let me get rid of this. There are your videos. Okay, so my calculator, obviously what I'm going to do is go to y equals. I want to type that function, negative 16x squared plus 76x plus 1. So you can see it. There it is. So if I have that on my function, on my screen, obviously, everything else in there should be away. I have that in Y2. Don't worry about that for right now. You'll see why a little bit later. So I'm going to do zoom 6. I always want to start with a standard window. Hopefully you still remember that by now. Okay, so I can kind of see my football. It goes up and it comes back down and hits the ground somewhere around 1, 2, 3, 4, somewhere in between 4 and 5 seconds. So think about that as we keep going. I know I'm going to have to manipulate my window. Remember, change one at a time. So I'm going to hit window. I know my Y max needs to get a little bit bigger, so I'm going to change my Y max. Remember, it doesn't matter. We're kind of guessing at this point. I'm going to change it to 100 and see where that gets me. One at a time. See if that's good. There's my football. It goes up. It looks like that's good. Looks like I have that. Looks like I don't need to go any further than that. So let's kind of head back to our, okay, so there's my graph. I got that. I think it said to find after how many seconds did the football reach its maximum height? So think about it, what I did for you. I wrote my window. -10, 10 by -10, 100. It's going to be important that you remember those windows, especially when you're studying. You want to make sure you can see those windows before you keep going. So when did it reach its maximum height? I know that what I need to do on my graphing calculator is to find the max. How do I find the max? I know I hit the second button and then the calc or trace. Once I do that, number 4 is the max, so I'm going to hit number 4. Okay, so now it's going to ask me 3 questions, left bound, right bound, and guess. So I gotta be somewhere to the left of my maximum. Okay, so there it is. I'm gonna hit enter. Somewhere to the right. Yeah, that looks good there. So I'm gonna hit enter again. And I could guess, or I'm just gonna hit enter one more time. And there it tells me the max. I know the X is the time. I know Y is the height. So be careful. Think about that. X is time. Y is the height. So if I go back into my notes, how many seconds did the football reach its maximum height? Well, X is the time. So it's got to be the maximum height, approximately 2.37 seconds. What was the maximum height of this kick? Voila, we already have it on our graphing calculator. The height is the Y value that's on your screen right now. So I know the Y value is 91.25 feet. Letter D, to the nearest hundredth of a second. Hundredth is 2 decimal places. How long until the ball... Just dropped my pen. How long until the ball returned to the ground? That is obviously the hang time, how long it's been in the air. So if I go back to my graphing calculator, what was the hang time? How long until it returned to the ground? Think about the ground. I know that that's my 0 of my function. So what I need to do, let's go second and calc. Computer's slow today. I know when I hit second calc, what I need to do is, once it decides, there it goes. Number 2 is the 0. So, left bound. All right, so now I got to think about my 0. So, left bound. Oh, that's kind of close. Left bound, somewhere to the left of that 0. So, that would look like that. Right bound, somewhere to the right. I'm just going to go down there somewhere. Hit enter. Notice my arrows have trapped my 0. Guess. I don't need to guess. I'm going to hit enter one more time. And it looks like my 0 is 4.76 seconds. So if I go back up here, to the nearest hundredth for a second, let's think. I know that's the 0 of my function, so the 0 is approximately 4.76 seconds. Hopefully, this video was a little bit better. Tried to show you my graphing calculator, what was going on, and we'll kind of go from there. All right, so good job.